Okay, Jason, so floor is all yours.
Great. Um, Thank you very much for the invite. I'm glad that the scheduling worked out. Um, my name is Jason Morris. For those of you who aren't particularly familiar with me, my main interaction with the logic programming community is through the Blawx tool that I created first as a personal project and then with the Government of Canada, and now again as a personal project, which is a user-friendly interface for lawyers mostly, but legal subject matter experts to use the SCASP language to encode the meaning of statutes and regulations for usually public sector purposes. And um, beyond trying to figure out how to put a friendly user face on top of SCASP, I am not a logic programming expert. And beyond um, my own focus on trying to make logic programming more accessible to mostly legal professionals, I am not a programming pedagogy expert. So um, I'm coming to you with some ideas that are kind of randomly collected over the years about new things that we could be doing that we haven't done yet. And I may be saying things that you all already know, and I'll just ask for your forgiveness and patience in advance. Um, the so the I will. Can I share my screen?
Sure.
Yeah, great. So I will share my screen just to show you blocks for context. Um, I'll just get you to confirm you can see that.
Yes.
Great. So the programming interface inside Blawx is based on a visual programming library that was created by Google called Blockly, and it is very similar to the libraries that are used for the Scratch programming tool, which is used for teaching Python and JavaScript and languages like that to children predominantly. Um, but the over the last, I would say, 5 to 10 years, I think that the people who do the Blockly programming environment as a library have come to realize that the strength of this is not limited to its ability to help with education. And they've started to realize that there are more use cases for making certain kinds of syntax errors impossible than just teaching. And so it's been adopted in a lot of different places as a way of providing a scripting interface inside of other applications. And this this implementation in Blawx is another example of using the same tool for a thing that is not technically a teaching task. But what it is best known for is teaching, and so I'm familiar with a bunch of the tools that are used that use Blockly for teaching tasks, like Scratch and Make Code, and a number of them that are out there. They're specifically aimed at children, and I think that here I'll turn that off. I think that the main insight that comes from the way that these things are used to teach other programming approaches is that it does help. Um, the the benefit of the block format is that it eliminates some kind of syntax errors. It also eliminates the conflict in most programming languages between the language being readable and the language being quick to type. Um, the there is no if every segment of the language that you're adding to your code is a block, then at most what you're doing is you are dragging and dropping. And the cost of dragging and dropping is the same, regardless of how many words are on the block. And so you can afford to have your coding language be much more verbose and much easier to read by virtue of that, without costing yourself anything in terms of programming time. And so that's another one of the advantages that comes from it. It tends to be more readable, more readily. But what I have noticed about the tools that are most popular for, most effective, I think, for teaching programming to children using these block interfaces is that they do not, they usually do not appear to the children to be for the purpose of teaching programming. It appears to the children to be a game or a puzzle or something else that is inherently motivating for the child, and the programming language and constructs are just provided as a toolbox for the child to accomplish whatever it is that they're trying to accomplish. I think that's the right approach. I think if you wanted to have the best possible way of teaching programming in logic programming to children, it would be an approach that kind of hides the logic programming almost entirely. And it's just a set of blocks that they're pulling out in order to make rules, and then they can see how those rules affect some environment, like a game environment or a puzzle environment, and they can see. And this is one of the advantages of the Blockly environment. One of the things that's built into it is that it has a feature to allow you to highlight whichever segment of code is currently being executed. And so as your little character is walking around a map, the sections of code that are being used to make whatever the current decision is are being highlighted. I don't know how, in the logic programming paradigm, I don't know how applicable that is, but that idea of being able to see the code as it is doing what it is doing in the environment, I think is also very useful. And so that's kind of like, if I said, what is the one logic programming tool that I would like to see exist, I would like to see a Prolog version of Scratch. Something where there's a puzzle or a game that's visible on the side of the screen, there's a coding environment on the other side, a predetermined set of predicates and basic Prolog operators that they don't look like Prolog operators. They're not designed to look like Prolog operators, but they have the same effect. And then as the code is executing, you can see what the code is doing. And that last part is probably the hardest part. But it does work quite well as a language. In fact, I think it's fair to say that Prolog, a greater percentage of Prolog may be conveniently represented in Blawx than for most programming languages. Because right now, when they're teaching Python or they're teaching JavaScript using these approaches, they kind of have to stop at the point where you get to object-oriented stuff or where you get to complex data structures. Because the block language does not have a convenient way to represent these ideas, and there isn't a convenient way to visualize how that code is being executed in the course of running your program. And so most tools for programming, they stop at procedural programming and they don't go into the object-oriented capabilities of the language for that reason. I think that Prolog may have an advantage there. And let me, I'll share my screen again here. I created where did I put it? Let's see. I think I put it in the title of this law. Yeah, so this is just an example of, in the Blawx language, how are some of the basic concepts in Prolog represented. And you can see in Prolog, you've got the two characters to express the existence of a rule with the head and the body. And here, when we know conditions, we also know conclusions. And so that's an example of what I'm saying. Like, dragging this one block around is no more expensive than dragging around a block that had only these 2 characters on it. So this allows your coding experience to be a lot more verbose. It is, I will say, sometimes difficult to come up with terminology for the blocks that's going to be kind of consistently correct, but it's also a fun problem to solve. So I don't I don't think the person tasked with that would be too upset with it. This is what the query block looks like. This is what the head tail block looks like in Blawx. An equivalence. This is a user-defined predicate, an is operator, and negation is failure. So this is kind of what basic Prolog looks like inside Blawx. We have a lot of things in here that are specifically aimed at legislation and the kinds of problems that you're going to have dealing with legislation. Blawx is also more of a kind of a sorted logic, I think it's called. So we have categories, and symbols are created inside a category. And then once they've been created, they're visible for the user to reuse. And then, so this is kind of, I'm optimistic that a very large portion of what exists in Prolog that would be useful, particularly in the educational in the educational world. I think most of what you need is going to fit very well into this kind of a language, and I think you could have something that was really quite interesting. So that's my main pitch. Is I would very much like to see a scratch for Prolog. There are 2 other things that I wanted to raise before maybe we can have a wider conversation. But the first is that I think logic programming approaches like SCASP, where the generation of an explanation for the conclusion is kind of like a built-in feature of the language, or any other approach that's accomplishing the same thing. I think that explanations provide an educational opportunity that has not nearly been exploited enough. So here I can illustrate this as well. So let me take a look at something in Blawx here. We have a question in here about section 5. Oh, actually, let me show you the code for section 5, and then for context. So this is the code for section 5 of this rule. Very simply, if authority is the contracting authority for a contract, then we know according to section 5, the authority must solicit bids for the contract, right? Very straightforward. So then there is a question based on that section, and you can run that question with the fact scenario for that section, and it's going to generate an explanation tree. And the thing that, oh, that didn't work, did it? Oh, excuse me. I know how I broke it. Let me just, well, you know what? That'll take too long to fix. So let me just turn that off. So I'll ask you to visualize with me. The explanation trees that come back from SCASP and are displayed in Blawx. Those trees are very meaningful to me as the person who wrote the encoding, because I can see in them the structure of the rules that I wrote. Right? So at any point halfway down the tree, there's a sub-conclusion and its immediate child justifications. And that shape, on those two levels of the explanation tree, that shape matches the shape of a rule that I wrote. Right? So we can think of explanations as a Lego assembling of rules with a grounding thread that runs all the way through those Lego blocks. And I think that if you made that visually explicit somewhere, that there's all kinds of wonderful things you might be able to build that would give an intuition for how logic programming is working that is very difficult to see otherwise. So one example that I have is, and I don't know if this actually works. I've spent some time drawing pictures in a notebook trying to figure out if I could make this actually work. I have not satisfied myself one way or the other if it's possible. But the idea is, what if the rules are effectively molecules? And they have a polarity. So there's like the input end and the output end. And the input has individual shapes for each of the predicates that are conjunctively required to satisfy the rule. And the output is the head of the rule that has the same kind of shape, but with the opposite polarity. Right? And there are threads that connect the variables in the conditions to the variables in the conclusion. And for each of your rules, you have one of these molecules. And then the user interface for the child, for the person you're trying to teach logic programming to, is pour a bucket of rule A into your flask and pour a bucket of rule B into your flask. And then put in your catalyst, which is a query. And it has the same shape, except it only has the head. And you plop that into your bucket and stir, and watch these molecules compose themselves into a protein, or whatever analogy you'd like to make, which is effectively an answer and its explanation. And as you were watching these molecules form, you would be seeing recursion happen, right? Without, and I think this is potentially helpful in the earlier stages of teaching, without the user needing to understand how the resolution algorithm is working. We just put everything in a bucket and we mix it, and then they find each other and they connect, and what you get is these nicely finished strands. And when the strands are finished, those are the ones that stay. And other things might be assembled, but they can't really finish themselves. And so when you turn off the electricity or what have you, you take out the catalyst, then those strands kind of dissolve away. But the ones that were able to ground themselves, those are new molecules that will stay that way. And then you can look at them and see what they say and see what they mean. I think that's really intriguing as a way of illustrating the way that rules are combined and the threads form the grounding and the structure forms the explanation. I think there's some really interesting analogies that you could do, that you could visualize and create in ways that would be like, honestly, I think that would be fun. Like, I think I would have a blast playing with that, right? I wish that I was more confident that there's actually a way to make it work. You may have to limit the language in particular ways in order to make it work. I don't think nested predicates would work. I think that would probably get too complicated, but I think there might be a way, if you avoid nested predicates, that you could make that functional. And it would probably need to be in some sort of 3D. I'm not sure 2 dimensions would get you there, but that's an idea that has occurred to me in the past. Another idea that similarly comes from the advantage of looking at the explanation as the output instead of looking at the bindings is, I found it difficult, as a person who was learning to use SCASP with no real background in logic programming, I found it difficult to get an intuition for what the system was doing in the background. right? All abstractions are leaky abstractions. And eventually you get to the point where you need to understand how the resolution is working in order to be able to write the code effectively. So for this higher level where the resolution is actually part of what you want to teach, I think that there is an opportunity to change the way that traces are visualized in languages where the output is an explanation. I think you could do essentially the same idea as that molecule, except instead of trying to obscure the way that rules are connected to other rules in order to generate a grounded path, and instead of trying to obscure the idea that some things are searched that won't work and then are abandoned and backtracked, I think that you could illustrate all of that by imagining the current state of the explanation as like a chess position. And if any of you are familiar with how chess user interfaces work, for reviewing a chess game, you would have the top of the screen allows you to display a single chess position. And then often underneath, there is effectively a tree structure of the sequence of positions in a game. And then if you go back to an earlier position in the game and you want to explore a different sequence of positions from that spot, then it creates another branch off that tree. And then you can explore down that branch and try it and see what happens, and then go back to a previous thing. And as you're exploring all of these different possibilities at different points in the game, it's generating this tree illustration at the bottom that you can backtrack to wherever you were. The resolution process could be represented in that kind of a tree. And at each point in that tree, you would be able to see what the explanation, how much of the explanation had been built and what it was looking for next, right? And that would allow you to really kind of very intuitively look at what the system is thinking. I don't know if it could be done in real time. I think it's just a matter of taking traces and converting them into a different format and displaying them usefully. But again, it's not something that I've ever seen. And I think that it would have helped me a lot as I was going through the process of learning how these tools work. So those are a couple of thoughts about things that, I think might be pedagogically useful that could exist specifically when you're looking at explanations. And then there's one thing that I think is worth raising too, which is specifically with the block-based visual language. I think that we are going to have to admit that those block-based teaching tools were designed for a world of programming that no longer exists. They were designed for a system that was, the idea was, let's give it a portion of the programming language to children in this block-based interface, and let's build it in a way that it is sufficiently similar to the experience of using the actual programming language, that the experience will be transferable, right? Let's have the children generate code in blocks, but then also see what that code looks like if it had been written in Python or JavaScript or what have you, with the idea being that we want to transition the children to eventually being able to write the JavaScript or Python themselves in an IDE. I think the world of agentic coding has changed what the objectives are going to be. I have only really been working full-time as a programmer for the last 2.5 years or so. But in that period of time, I have gone from typing about 90% of my code to typing roughly 0% of my code. And I don't think that that's ever going to go in the other direction. So I think the aspiration of being able to transition people to a more friendly but less robust user interface to a text-based interface, I think that objective should be abandoned. I think a lot of the tools are designed around being able to do that, and I don't think it matters anymore. I think that what we should be looking at instead is finding approachable user interfaces that actually cover the field. That you're not sacrificing object orientation by using it. If it's Python, you're not sacrificing cuts or nested predicates or whatever it is if it's Prolog. You're trying to find a way of generating a user-friendly interface that is going to be able to cover the entire thing. And I think there, Blawx may not be the final solution, because I think that they are going to have, I think they're going to have limitations that are difficult to overcome in a 2D environment, but I think that you can overcome them in like a projectional editor style environment. So I think Blawx is a good way of approaching it in the near term, but I think ultimately the target is going to be something that is easier than the way we do programming now. Jason, I see you have a hand up.
I guess two questions while I had one and now I've got two continuing to listen. What do you think of that a beginner focused introductory programming environment should give up in terms of power user functionality in order to make that more user friendly in this new world?
Yeah.
And secondly, what kind of role do you think logic and logic programming has specifically in a meta programming respect in this new Gen AI coding world?
Yeah. So on the first thing, I think if you're looking specifically at the pedagogical approach, my attitude would be don't put anything in the user environment that isn't absolutely necessary for solving the current problem. And then have a series of problems where features of the language are being added. And the reason for that is not because I know particularly much about teaching programming, but because that's how my favorite video games work. That's how my favorite board games work. They start with a smaller version of the rule set and they build you up as they go. So that's what I would be inclined to recommend, is to eliminate everything that isn't absolutely necessary and build a series of problems that brings you to the full language. On the second question, this is less to do with teaching, but my current exploration with Blawx is, so Blawx is based on SCASP, and what SCASP is giving you is partial minimal models and with constraints, right? And what so one of the things that I've struggled with is that using SCASP and using Blawx, at least the way I'm doing it, is not terribly computationally efficient. The code tends to be slower than you would want it to be for running a web app. And so one of the issues that I've been trying to solve is how do we make this encoding, which is very good at representing what the lawyer thinks the rule means, and how do we make it something that's useful for a software developer who needs to build a web app that helps people determine if they're eligible for something. And it has occurred to me that if I use the abducible reasoning features in SCASP, then I can generate these constrained partial minimal models that kind of represent all of the ways in which the query could potentially be true, right? It's not expressed in like exhaustively, but expressed as a set of constrained categories. If I can take those and I can give them to a coding agent, and I can say to the coding agent, take these models and convert them into property tests in whatever language you're using. And so a property test, if you're not familiar, is unlike a unit test where it gives you an input and the expected output, and you got yes, it worked, or no, it didn't. A property test is here are the properties to check about the inputs. And if these tests are met, then these things should be true about the output. So it's a conditional test that's applied to all kinds of inputs. And the idea is if you build a bunch of these property tests, then you can randomly generate inputs, as many as you like, and all of them should pass the property test. Because where it applies, it should match, and where it doesn't apply, it should be ignored. So my thought is these models can be converted into property tests. And those property tests can then be given to the coding agent as a way to figure out whether or not the software it wrote is compliant with the encoding expressed in Blawx. And so I think that there is I think that will work. I'm just at the very early stages of testing it. I've done some toy examples. The actual problem that I have in proving that this works is that the coding agents are so good, it's very difficult for me to demonstrate that the SCASP encoding mattered. They're so solid in terms of their ability to write the code that I have to find something that's complex enough that the SCASP encoding is actually giving advice that the coding agent couldn't have figured out on its own, right? And I haven't gotten to that point yet. But assuming that it does work, because I think it will, it's very interesting to think that what this would be is it would be a system whereby a lawyer is given a tool that in the background is generating a logic programming representation. And then that logic programming representation is being used as a specification for software written in another language. A testable specification that a coding agent can use to check its own work. And what you end up with is the lawyer, who doesn't really know that they're using a logic programming language, generating a testable specification that enables a coding agent to write code that it wouldn't otherwise be able to build. So that's kind of my current guess, is that I think that as we go forward, logic programming tools, if we make them accessible to the people who have the knowledge that needs representing, we can do a lot in terms of like formal verification that has not happened before. And with that combined with coding agents, it's going to be very valuable. I hope that answers your question, Jason.
Thanks. Great stuff to think about.
Can I come
please.
in and query you, Jason?
Yep.
I'm afraid I didn't understand much of what you were explaining. We've also tried using or have successfully used SCASP for legal applications.
Mm-hmm.
And what we've exploited is SCASP's ability, as you've described it, to give conditional answers. So if you describe a scenario which is incomplete, and you ask whether or not, for example, in an insurance application, whether or not a client is covered for some claim that the client has made, it will say, yes, the client is covered as long as the accident occurred in the course of which is insured. So that would be a condition.
Yep.
Now, from what I understood of what you were saying, what you have appreciated in using SCAPs is the provision of these conditional answers, which are like and this is where I'm not clear. When you use the term property, do you mean a condition, or do you mean something other than conditions on an answer to hold?
Yeah, so the word property is overloaded here. The property test is the term that's used for this particular kind of software testing approach, where instead of a unit test that is testing whether specific inputs give a specific output, a property test doesn't know what the input is and doesn't know what the output is, but it accepts both of them, and then it checks to see if the input falls into a certain category. And if it does, it checks to see whether the output falls into that same category. So a concrete example is if you are testing a piece of code that is for multiplication, right? It accepts two inputs and it outputs the result of the multiplication. A property test might say if the first factor is 1, then the output should be equal to the second factor.
Mm-hmm.
Right? That's a property test.
Okay.
Anytime you do a multiplication, you can run that test. And what you're going to learn is one of 3 things. 1, the test doesn't apply. 2, the test applies and passed. Or 3, the test applied and failed. And so that's what property testing is. And so the idea is that if instead of leaving out the unknown things in a given fact scenario, you just treat all of the input facts as unknown, then your encoding will give you the list of all of the possible types of models that would get to that conclusion. And those are the things that can be converted into property tests.
Jason, and Bob, can I interrupt there a little bit? I just wanted to draw your attention. I totally agree with what you said about the property-based testing and so on, and the fact that actually, if you have a way of specifying preconditions and postconditions, you can use that to guide, the performance of a coder, of a coding agent, and I mean, and we do this all the time in practice. We put tests and we say, okay, code so that it will pass the test and so on.
Yeah.
I want to draw the attention to, in the child prologue language, we have assertions like that. So we have preconditions and postconditions, and the properties is the right name. I agree. The properties that you put in the preconditions and the postconditions are prologue predicates, and this is much more interesting than what is done in property-based testing, and it's actually, even older in the sense, because you see, prologue predicates generate. So this idea that if you state that something is, I don't know, a list, for example, the input is a list, or is an integer, like you're saying, of a multiplication, of a list, of a pen. If the input is a list and you want to generate lists, the only thing you have to do is to call list, to call the property, because the property will be written in prologue, and it will generate test cases for you.
Yeah.
And then, so it's exactly what you were describing. So this
It's
is the testing model and the unit testing model in Chow Prolog. So
yep, that's very much the same idea, except the version of it that I'm doing is designed to get the knowledge that's in the logic programming and give it to the coding agent so that they can re-express it in whatever platform they're using. Yeah.
Just very quickly. Oh no, I got. Okay, go ahead, David. I'll come back.
Sorry. I guess what I'm asking is this an optimization thing, a translation issue? Is it the fact that SCASP does exactly what you want it to do, but it just does it too slowly? And so what you're really trying to do is to optimize it, and you're going to do that by having it translated into a more efficient language?
It's not exactly that, because the motivation within Blawx is for the representation of the law to be as reusable as possible, across as many applications as possible. And that has advantages, not just from an automating things you already know standpoint. Blawx is not just a tool for taking a well-defined understanding of a piece of legislation and turning it into software, right? Blawx is also a tool for exploring understandings of legislation. And so it gets used to encode possible pieces of legislation to see how they might behave, and then say, oh, well, that behavior is not what we wanted, and then to kind of fine-tune, adjust your understanding of what the legislation needs to be so that the encoding can actually inform what the text of the law should be. So that's more of a back and forth kind of a process. And the expectation is that at the end of that process, there are going to be developers who want to reuse the knowledge in that code for whatever thing it is that their software needs to do, which is typically going to be a very small subset of the things that the logic program is capable of handling. And so it's not just about translating SCASP code into equivalent code in another language. It's about if these are the only things that my software needs to get right, if these are the 3 queries that I'm actually asking in my user interface that's for determining specifically whether or not people are qualified for this benefit,
So,
then how do I extract out the knowledge that is about asking those questions in particular?
so that's like a partial evaluation kind of a concept.
Yes. It's
Okay, so
more
it's
like
like
a partial
evaluation and optimization
and
are
into a separate language. Yes.
Okay, thanks.
Yeah, and I think David asked my question in a slightly different fashion. That is to say, how do you actually use this in a legal context? I'm still not all that clear about your answer, though, to be honest with you.
Yeah, well, the SCASP encoding in Blawx is able to answer all kinds of questions. Like it's able to answer, in uncertain information, what else would need to be true for this conclusion to hold. It's able to reason in reverse. It's able to reason over, negation is failure. It can do all of these useful things that are very useful when the lawyer is trying to validate whether or not the code represents their own understanding of what the law does. But when you get to the point where developer A needs to build a web application that will tell people whether or not they are entitled to old age security, it's a small subset of what the program is capable of doing that you actually need in order to build that software. There's a number of queries against the SCASP code that piece of software needs to correctly replicate. And so this process is just where you can say, okay, here are the questions that this other application is going to have to also get right. And then treat all of the inputs as abducible, generate the minimal models, and use the constraints in those models to build property tests. And if the software passes all of the property tests, then it is answering those queries in a way that is consistent with the SCASP code. It's not able to answer any other queries that the SCASP code can answer, but it's consistent to the extent of those questions.
Then I don't see the need or the desirability of translating this into a faster or more conventional computer program, because we can do that very efficiently in Prolog.
Yes, and I am not as familiar with Prolog because I deal primarily in SCASP, and I am also not enough of a logic programming expert to really understand the scope of the efficiency that can be obtained. But working inside the government of Canada, even if the Prolog code was as fast as you needed it to be, it was not feasible to have the developers working in the department learn Prolog sufficiently well in order to integrate Prolog into their applications. It was just a non-starter for logistical reasons. We're hiring outside consultants to develop the software, and they have no experience with Prolog, and they have no intention of gaining any. And if we expose something as an API, then we're doing all kinds of more complicated things, and everyone is just constantly complaining. The nice thing about this approach is that it eliminates the need for the logic programming representation to be performant in that way. It no longer matters. And maybe more importantly, it eliminates the need of the person who's responsible for actually building the web app from knowing anything about Prolog, knowing anything about SCASP, knowing anything about the logic programming. They're able to use it without understanding it. So that's the main motivation. It's not fundamentally a performant one, although in my particular case, Blawx is not terribly performant. But it is also this kind of like, let's get it so this code is useful to people in a way where they don't need to adopt new platforms.
Jason, sorry to interrupt, but you say something more. You said that you are not writing any more rules. You went down to 0% more rules. That's because you already have them, right? Not because something else is writing it for you.
Sorry, I didn't catch the start of that.
Yeah, sorry. I'm talking about you said something about not writing any more rules now in Blawx. Because you already
Oh, do you mean when I said like 0% of
yes.
this coding that I'm writing? Right. So I was talking about in my professional work where I am writing in typical programming languages like SCASP like Python and JavaScript. In that work, I'm no longer writing any of my own code. But to your point, well, let me share my screen again. The encodings in this is a code generation test. So all of the encodings in here were generated by an AI coding agent. I think this is probably the most complex section of code. Yeah. And so all of these rules were written as an encoding of the corresponding piece of legal text by GPT 5.4 inside GitHub Copilot using an MCP server for Blawx. So I'm not yet at the point where anything else is writing all of the rules, but I am actively exploring how to make the AI agent the way that the first draft is written.
So this is done from what? From some specification from the rules in the law or something?
From the text of the law. Yeah.
Brilliant.
Yeah. So it's just reading the text of the law, and it has some information about how Blawx works, and it has some information about the best practices in terms of generating the rules and like referring to sections and so on and so forth. So there's a lot of stuff in the MCP server that's trying to educate the agent on how to use Blawx. But yeah, right now that's what my current when I keep telling people my work with Blawx consists of about 3 hours on Saturday mornings while I'm waiting for my middleest child to get out of rock climbing lessons. So I've been spending 3 hours on Saturday mornings for the last 2.5 years, and currently my 3 hours on Saturday mornings is spent trying to improve this AI agent-based code generation feature. And I've just literally this past weekend, I got to the point where the output was illustrative enough that I have begun sharing it with people. But yeah, that's kind of, and it's promising. Like it's genuinely, it's because the way that the new version of Blawx work, it separates out predicate definitions into a completely different task. So the agent is being given a very specific set of steps to follow. Read the section of the law, figure out what predicates you would need to express this in a logic programming language, generate those predicates, check to see if they already exist, and if so, fine. If you need new ones, then create the new ones, and then here's the instructions on how to create the language, and then actually generate the encoding. And what it's outputting is a JSON representation of the actual visual blocks that will show up in that interface per section of law. And it's doing that reliably enough that it turns out to be valid JSON, valid blocks, and a relatively solid semantic representation of the meaning of the text. About 90% of the time. And then when it isn't, the agent also has access to the ability to create fact scenarios and to create questions and to run its code and read the natural language explanations and see if they actually confirm that it's behaving in the way that it wanted to.
So it's the whole byte coding stuff, right? Testing the output with your tool to see if it runs.
So what's happening is I'm saying to the agent, please look at the rules that are in the current Blawx project and encode them. And then it is going section by section. It's creating vocabulary. It's creating tests. It's creating fact scenarios. It's doing the encoding. It's running those tests against the encoding, and then fixing the encoding if it's broken, fixing the tests if they're broken, and then proceeding to the next section of the law and repeating.
Right.
And so that package that I've got right now, it ran for about 15 minutes to generate, I think in the range of like 9 or 10 sections of law. So this is, to my point, if the coding agent can write Blawx code and can collaborate with a human expert in the Blawx environment, then we don't really need a person learning programming languages to ever be able to type them. What we need is the best user interface that both the target human user and an agent can use. And that is the thing, that's where the work is actually going to happen. And so that's what we're going to need to train toward. And I think, honestly, the broader idea, like the thing that makes me most excited about rules as code, the reason I got involved in representing legal ideas in programming is because I was a programmer, I was trying to build things, I was frustrated with how inefficient the code writing task was. And then I discovered logic programming approaches, and I realized this is a much more structurally isomorphic way of writing the code. Like I can take one section of law and correspond to one section of code. This is going to be easier to maintain. When I write the one set of rules, it's able to answer more questions. I don't have to write an algorithm for finding one thing. I can write a set of rules and let the reasoner find the algorithm. This is all wonderful. And then as I started to explore it more, I realized that I was taking a law that I thought I understood and doing the encoding of that law and learning that I had not really understood it. And I think that it doesn't really matter what the user environment is. It doesn't really matter what the specific formalism is. I think that if we can get more people doing more formalisms in a logical approach, they are going to have that same experience, and they're going to say, wow, just by trying to encode this, I understand it better now.
Exactly.
And that is such a wonderful experience for people. All of the lawyers that have used Blawx inside the government of Canada have said that they genuinely enjoy the experience of learning what it is they hadn't yet thought of by going through the process of trying to encode. And even the lawyers who don't want to use it themselves, maybe they're a little old school or they're technologically averse or what have you, even those lawyers say, I'm not going to use Blawx, but I would really like it if my clients did. I'd really like it if the people who are asking me to draft legislation would just think harder about what they want the legislation to be and use Blawx as a tool for thinking harder. And then they would come to me with much more precise expectations and specifications for what the draft actually needs to say. So that's my big motivation, and I think there's a million ways we can get there, but we should get there.
I think that's exactly that's. We've been talking about teaching critical thinking and logical thinking, and what you're talking about is exactly what critical thinking does. It helps you understand what clarify your thoughts. Christian, that was his old point when he does art. He uses logic programming in art, and the whole idea was to experiment with the art to clarify what your ideas are. And so it wasn't so much that you produced a program, it was that you clarified your thinking. That was the purpose of writing these logic programs. And I think I have another thing I just want to point out I think is really interesting that I hadn't seen. And you emphasized early on explanations, and I think you're exactly right. A proof is an explanation.
Yes.
And that's really important in order to understand what's going on, or what you're, how you're thinking. But I did notice that your templates had for a rule, it had where the rule came from, which is not a logic programming thing. You had it according to, I think was what it was,
Yep.
And that according to is, I think is really intriguing because it's not something I normally think about when I'm writing a Prolog program because,
Right.
there's no place to put that in. But
Right.
if you're trying to encode knowledge, that's can be a very important piece of knowledge that can be connected into your explanation in a way that's, I think, illuminating and enlightening. So I think that's yet another part of how to put knowledge into a logic programming framework in a useful way that's
Yep.
can be used. Anyway,
Yeah.
I just thought that was a very neat idea, and I think
And-
I think it can be much broader than. I mean, I guess I don't know. I'd like to explore to see whether it could apply in more areas than
Yeah.
than law.
Yeah, I think it can. I think it's particularly valuable in the legal application because in the legal application, there are these external artifacts that we want to be able to refer back to. There is a section of a law somewhere that means something. That was the source of the semantic meaning of this encoding. And so let's tie it back. In Blawx, as you're looking at the explanations, you can actually hover over the section references, and it will show you the text of that section of the law. And so that being able to tie it back to the source material is extremely important in the legal application, but it clearly has utility elsewhere as well. Perhaps, maybe I don't know what the right level of specificity would be in a more general programming task, because what you might be more interested in is not the specific rule or a source concept, but there may be other ways of from this library, there's some other idea that you could point to and say, this is a useful piece of context for where this portion of the explanation was delivered from. But yeah, in the legal context, that's extraordinarily valuable.
Great. Yeah. Thanks. One other thing, you're talking about your model. I'm sorry. Go ahead, Vladik.
May I have a question, namely about that story that some other person would encode that in some other language. How a person could reliably encode in other language what a logic program does without understanding the logic program?
They would need to understand the okay, so what I'm going to do is I'm going to abstract away the question of whether the person writing the code is a person or an agent, right? I don't know which of them is going to be more relevant, but if you have these constrained minimal models that express all of the ways in which a particular conclusion can be reached in your logic programming, and if you understand the predicate language that's being used, and if you have a reliable mapping between expressing facts in those predicates and expressing facts in whatever programming language you're using, then what you can do is you can generate the property tests that correspond one-to-one with those minimal constrained models. And then that combination of property tests is a definition in your other programming language of the correct behavior of answering that query. And then you just use those to determine whether or not your programming is following it. So what you need to know is you need to have the predicate language, you need to have a mapping to your own data structure, and then the ability to generate property tests from the minimal models. You don't need to know anything about how the minimal models were generated. You don't need to know anything about the law that you used to generate the code. You don't need to know anything about the code that was used to generate the models. You just need that set of minimal models and a good way of doing a data translation. And
the property tests are implemented in logic programming.
No, the property tests are implemented in the target language.
But then, so how do you? So my problem is, my question is again there. How do you make reliably property tests without understanding the specification, which is a logic program?
The logic program is not the specification. The minimal models are. Because,
okay, so but you don't know minimal models. You know only the logic program. There are infinitely many minimal.
No, that's the mechanism. Is that if I want to write a piece of code that correctly answers the question, who is entitled to this benefit, then what I do is I go into Blawx and I create the query, who is entitled to this benefit. I make all of the inputs values abducible. I run that query, and the response that I get is a set of minimal partial models with constraints. That is enough. That set of minimal partial models with constraints is all of the information that is. So I had a conversation with a friend 3 or 4 years ago in Singapore, and I explained to him SCASP, and this is maybe one of the smartest people I've ever worked with. I explained to him SCASP, and I explained to him what the output of a query in SCASP was and how it was different from other Prolong approaches. And he just kind of tilted his head to the side and squinted his eyes, and he said, so the output is another program for answering the same question? And I said, oh, yeah, it is. The set of stable models is another program for answering the same query, just expressed differently. So that is all you need. If you have that set of minimal stable models with constraints, boom, you have a specification for how to answer that query. You don't need to know what the original code was. You don't need to know what the original law was. So
but
that's where the...
Mm-hmm.
Go ahead.
But it seems to be only about this single query.
Correct. And so you do that again for as many queries as your target software needs to get right.
A very small question. What do you mean by nested predicates?
Oh, where one of the parameters of a term is a functor with its own parameters.
So I think if there are structures as arguments of predicates, I believe predicates with structures, basically complex structures.
Non-data log?
Not data log, I guess. Yes. Right. That's what you mean. I think.
I'm not great with the terminology, but that sounds right to me. Yeah, I'm saying if you another way of putting it, only one pair of parentheses. I think that might be useful.
Right. So basically, data log. Yeah.
Yeah.
And can you explain what you mean by partial stable model with constraints?
I think you should ask Gopal because he will explain it much better than I do.
So that's
okay,
basically.
So let me say what I think. You mean you don't mean stable models at all. I think you simply mean the conditions that would need to be satisfied for the query to hold true. There's no need to talk about stable models. In fact, stable models is not only a distraction but potentially an unuseful distraction. But what do you mean by constraints? Do you mean that these conditions could be thought of as constraints? Because why not just simplify it all and say what are the conditions needed for the conclusion or the query to hold true? Why all these extra qualifications concerning partial and concerning constraints?
I mean, for the most part, basically just my own lack of familiarity with the terminology, probably. Your intuition is almost
constraints may also mean, I think, arithmetic constraints. Are you using arithmetic constraints?
Yes, we are.
That's
using
what he means.
Arithmetic constraints.
So arithmetic constraints are supported in SCAS. So I think that's what he means by constraints, not the denials. That's why Joaquin likes to call the actual constraints denials. What we call integrity constraints as so those are not integrity constraints. He's talking about actual arithmetic constraints that SCASP supports.
Yes.
Okay, so this could very simply be generated by reasoning backwards from the query and simply giving as an output what conditions you cannot verify to be true. And they can be either abducible predicates or they can be constrained arithmetic predicates that have variables that you don't want to instantiate.
So the main thing that helps here is, I think you could say, constructive negation, because you can just simply ask, negate anything you want without having to worry about, floundering and, soundness of negation as failure, etc. So I think that actually is the main thing that helps here, that in SCAS feature that helps you. You can basically negate anything you want and it will correctly compute it.
Right. Good. Okay. Thank you. Can I also defend Jason with respect to this input-output? So what you lose when you generate these properties, I think, you lose all these intermediate predicates inside the proof. And that's because you're not interested. If all you want to do is optimize answering a query, given some inputs, you don't need to know all those implicit auxiliary predicates that you would have either in the legislation or in the logic program.
That's right. In the use case that I'm talking about, where we're generating property tests and then those are being used to generate code in another language. Interestingly, I rather wish that I had a language or an approach or a method for writing tests that checked for certain properties of the explanation when running a query in SCAS. Because as a lawyer, when I'm doing my encoding, what I might be interested in saying is that I have this fact scenario, and when I run this fact scenario, I should get this binding against this code. I should get this binding in the answer. But also, whatever bindings I get should include that this section of the law was activated by virtue of this section of the law. So I don't care what the absolute explanation structure was. I don't care what the specific bindings are, but any time the answer to this question is true, it should be true because section 5 activated section 2. And so that's a thing that the lawyer might want to express about the explanation. And so in that case, I am interested in being able to write tests like that. I haven't really explored how to, but that's a scenario where the intermediate steps I want to keep, because that's what I'm actually interested in.
So you may be able to actually state that through the denials or the integrity constraints. You might say, this is the kind of answer I'm looking for. And in this situation, this predicate, this variable should have this binding. So you can actually express that as an integrity constraint or denial, basically.
Mm-hmm.
That's part of SCASP.
I'm very confident it's possible. It's just one of the very many things that I have never gotten to the point of being able to try.
The only thing may be how to express it in Blawx. I don't know.
Yes, I would probably need something more friendly than
design something in Blawx.
Yeah, those denials do exist in Blawx, but I've never been very successful at getting the lawyers to.
So interestingly, this also reminds me of system assurance is also a big field where they do something very similar, where you have a claim and you have to establish the claim, and there are arguments and evidence, and so and they have actually also used SCAS for automating some of that process. So it seems to me that another application of Blawx could be, the system assurance. Very much, the arguments are very similar, like, what you have in legal reasoning.
Yeah.
Maybe I'll share a paper with you on that. So new application potentially for Blawx.
Yeah, I think that's very much true. My bias is towards the legal thing because that's where I approached it from originally. But as I go through the process of building it, it's evident that there are
many other
enormous use cases elsewhere as well. So,
Jason, how do you represent variables in Blawx? And I know you said that they're sorted or typed, but what if you have this two variables of the same type in a same rule? How do you distinguish between them?
So the it's the typing is weird. In the coding interface, it doesn't really distinguish between symbols and variables, and it doesn't know unless you're talking about specifically dates, numbers, things that are the basic data types that it has. Symbols that are put into a category, it's not able to distinguish between a symbol that is in the category and a symbol that isn't. So there's no type checking in the user interface for that. The main reason for having the predicates, when they are defined, all of the parameters are given a type that is either one of the basic data types or one of the categories that has been defined by the user. The main reasons for doing that are twofold. One, when you give that information to the coding agent is smarter about how to use the predicates. It's useful context for having the agent do the coding. Two, when you want to automatically generate user interfaces that allow the user to fill in slots, there it is useful for the user interface to know what category is supposed to go in here. That
Can you just example? How do you define parent of mother?
Yeah.
X is a mother of Y, then X is a parent of Y. How do you
Right.
do you
So
have
that
do you have X's and Y's, or do you have a person and the person? How do you do that?
So right now it's done without any type inference. Basically, it checks the code to see type declarations, and then it will see that if something was declared as being a person, then it is a person, and it will show up in the user interface as a person in the drop-down list of people. But if what you're looking for is an inferred category, right now it has no capability for that.
No, but how do you represent the rule and the rule itself with variables? How does the rule look?
Like it's the categories are just unary predicates. So it would be a rule when A is a person, A is a entity.
Okay, so it would be A and B. So when A is a mother of when a person A is a mother of a person B, then A is a parent of B, something like that, or
Something
not?
like that. Yes.
Mhm.
Yeah.
So you would also have symbols in addition to, so you're using symbols, A and
Yeah,
B.
the symbols are used for concrete concepts and put into a unary category by default. Not by default. By the user interface forces you to use a category declaration, to use a unary category predicate in order to create symbols. So you can't create a symbol without having given it at least one category. You can then give it additional categories explicitly, and that will show up in the user interface. But any implied or derived categories won't show up in the front end. So it's
okay. Maybe I should reveal why I'm asking these questions, because as you gave your talk, I could see how these blocks that you move around could have been uncolored and could have been just sections of English. So you could take English text with holes in them, and you can move them around to create new English text. So that what you end up with is something like what we call logical English. So it's not a set of blocks. It's just a new text written in a stylized form.
Yeah, and there is nothing like so. What Blawx is, it's a combination of this visual block-based language. It's also effectively a way of generating a constrained natural language, but those are two benefits that there are other ways of accomplishing, right? Like getting rid of the risk of syntax errors and using constrained natural. You can also do that through a projectional editor. There's lots of different ways of accomplishing that same objective. And I don't pretend to think that Blawx is the only way to do it or even the best way to do it. The reason I built it using a visual block language is because when I started the project, there were no open source projectional editor libraries. But there was an open source block language library. So it's there are other ways of doing it, and I may end up exploring them. One of the nice things about this new world with agentic coding is that 7 years ago it would have been completely infeasible for me to start writing a projectional editor, and that's maybe no longer true. That might be a thing that I could actually do with the help of AI coding agents now. So yeah, so I don't pretend to think that the block language is in any way the only way to do it, but it is a good way.
Yeah, very much.
So we have gone past the hour. Maybe
Yes.
we thank Jason and
Yeah, thank you so much, Jason. It was a very inspiring talk.
yes, very interesting and yeah, very nice.
Thank you. And
My pleasure, absolutely.
Raised a lot of discussion. It was great. Thanks.
thank
Yes.
Yeah.
Thank you.
Thanks, everyone. Nice to see you again.
you again. Bye-bye.
Bye.
Bye-bye.
Bye.